Proving congruence, hypotenuse-leg. The final shortcut to proving congruence is hypotenuse-leg triangle congruence, or the HL triangle congruence for short. This theorem states that if two right triangles have their hypotenuses and a pair of legs congruent, then the triangles are congruent. The HL triangle congruence can be considered a corollary of the SSS triangle congruence. In a right triangle, the sum of the squares of the lengths of the two legs equals the square of the length of the hypotenuse. C squared equals A squared plus B squared. To prove the HL theorem, we will use algebra. So given A1 equals A2, C1 equals C2, and angles C1 and C2 are right angles, prove that the triangles are congruent. The plan is to show B1 equals B2, which makes the triangles congruent by the SSS postulate. By the Pythagorean theorem, C1 squared equals A1 squared plus B1 squared, and C2 squared equals A2 squared plus B2 squared. First, we solve for B in both equations. So B1 squared equals C1 squared minus A1 squared, and B2 squared equals C2 squared minus A2 squared. Then we substitute C1 equals C2 and A1 equals A2. So then we substitute them in each other's equations, and we get that B1 equals B2. Therefore, the triangles are congruent by the SSS postulate. Hypotenuse-leg example. Are the triangles congruent? These are right triangles, so look for HL triangle congruence. In this example, angle B and S are right angles. Segment AC is congruent to segment RT, and segment BC is congruent to segment ST. This is the information needed: right angles, congruent hypotenuses, and congruent legs. The hypotenuse-leg theorem states that if two right triangles have congruent hypotenuses and a pair of congruent legs, then the triangles are congruent. Here's the theorem in action. Given that angle B and angle S are right angles, AC, this line segment here, the hypotenuse, is equal in length to RT, the hypotenuse here, and BC, this leg, has an equal length to this leg here, ST, prove that the two triangles are congruent. So we start with our given information. Since the lengths of these line segments are equal, we know that those line segments are congruent, since that's the definition of congruent segments. And since we have congruent hypotenuses and a pair of congruent legs, and we have these right angles in there, we know, due to the hypotenuse-leg theorem, that these triangles are congruent. Proving triangles congruent. Definition. Two triangles are congruent if and only if corresponding angles are congruent and corresponding sides are congruent. Fortunately, to prove two triangles congruent does not require showing all 6 corresponding congruencies, but only 3. SSS congruence needs 3 pairs of sides. SAS triangle congruence needs 2 pairs of sides and the included angles. ASA congruence needs 2 pairs of angles and the included sides. AAS triangle congruence needs 2 pairs of angles and non-included sides. And HL triangle congruence needs pairs of hypotenuses and legs in right triangles. Note, SSA is not a justification for triangle congruence.